Hello friends, welcome back to one another video of CrackGate Online, and this is the continuation video of last lecture series, last lecture on IC engine. So today I will be covering IC engine part 2. I am Rakesh Ranjan. I did my MTech from IIT Kharagpur in 2015 and my gate rank was 31 in year 2013. So I will advise you, please keep your pen and notebook ready, and will starting this video lecture series with one numerical um, which was asked in GATE 2007. So let's go through this numerical first, what it is saying. The mechanical efficiency of power tiller engine develops 7.5 kilowatt is 80%. 80% is mechanical efficiency of power tiller. The calorific value of diesel is 45 megajoule per kg. If the indicated thermal efficiency is 35%, the brake specific fuel consumption of the engine is how much? Okay, this is the question. So what are the data they have given? Mechanical efficiency is given, 80% is the mechanical efficiency. Engine is developing 7.5 kilowatt. This much it is developing means this is brake power. Okay, brake power is given and mechanical efficiency is given, so you can find out the indicated power. Indicated power will be brake power upon uh, mechanical efficiency. So IHP equal to 7.5 upon 0.8 will be your indicated horsepower. Okay, then calorific value of diesel is 45 megajoule per kg and thermal efficiency is 35%. Okay, so this is indicated horsepower. Second way of calculating indicated horsepower is calorific value of fuel into fuel quantity into thermal efficiency will give in indicated horsepower. And they are asking about fuel consumption, means fuel quantity they are asking. Okay, so calorific value is given 45 megajoule per kg. So 45 into, suppose fuel quantity is F, into thermal efficiency is 35%, means 0.35 equals to IHP. So IHP is uh, 45 into F into 0.35. uh, we can equate both because both are indicated horsepower. So 45 into F into 0.35 equal to 7.5 upon 0.8, and keep all the values in SI. Okay, so when you will calculate F from there, your fuel consumption will come. So F will be 45 into 0.35 into 0.8 upon 7.5. So after calculating this, the value that will come will be 0.286 kg kilo per kilowatt per hour, kg per kilowatt per hour. So this is a specific fuel consumption of the engine, which value is 0.28 kg per kilowatt per hour. So answer will be D. And here 45 I was saying, so 45 is megajoule, so 45 into 10 to the power 6 will be the value, and this is 7.5 kilowatt, so 7.5 into 10 to the power 3 you will keep while calculating the values. uh, Here one more question. This question was asked in GATE 2015. Brake power of 6-cylinder 4-stroke diesel engine running at 300 rpm is 125 kilowatt. Brake power, brake horsepower value is given. Its brake specific fuel consumption is 200 gram per kilowatt per hour. Assuming specific gravity of the fuel as 0.85, the volume of fuel to be injected per cycle per cylinder in ml is asking. Okay, so This is SFC value. Okay, so fuel consumption, if you want to calculate, so fuel consumption will be specific value, specific fuel consumption into power, right? Because specific fuel consumption is kg per kilowatt per hour. So if you will multiply kilowatt with kilowatt, you will get gram per hour. So 125 into 200, if you will do, that is SFC into power, you will get amount of fuel consumed per hour. So 125 into 200 gram per hour of the fuel is being consumed in the engine. Now uh, question is asking amount in ml. Okay, so they are not asking about the weight of the fuel, but they are asking about volume of the fuel. So you will need to convert kg into ml. So for that, you can see here specific gravity of fuel is given. So if you will multiply this value with specific gravity, so mass will get converted to volume. So 125 into 200 into 0.85 will ml per hour. So this much ml of fuel is being consumed per hour. So when you will calculate, it will come 21250 ml per hour. So this is fuel consumed in 1 hour, but you want per cycle, right? If you will see the question, they are asking per cycle per cylinder. So for per cycle, you will need to divide it with revolution per hour, because suppose in 1 hour 3000 rpm revolution it is taking, right? 3000 revolution per minute. So in 1 minute 3000 revolution engine is taking. So in 1 hour how much it will take? 3000 into 60 revolution. 3000 into 60 revolution per hour. So in that much of revolution, this much of fuel will be consumed. So fuel consumed upon revolution per hour will give how much fuel is being injected per cycle. Okay, so how much will be the value? 21250, that is fuel consumed upon 3000 rpm into, to convert it into r, you will multiply it by 60. So so 21250 upon 3000 into 60 will you will get fuel per cycle. Okay, now you want amount of fuel per cylinder, and there is 6 cylinder. So in 1 rpm, how much will be the number of power stroke? This is 4-stroke engine, you know. So in 4-stroke engine, number of power stroke will be number of cylinder upon 2. So 6 cylinder is there. So number of power stroke in one revolution will be 3. So total fuel coming is this much fuel per cycle upon n by 2, that is 3. So whatever value you will get here upon 3 will give fuel per cylinder. So when you will calculate these value, final value come will be 0.039 ml of fuel per cylinder. Okay, so per cycle. So this they are asking. So its answer will be 0.039 ml per cycle per cylinder. So here is one more numerical which was asked in year 2020. So let's go through this numerical. A 4-cylinder 4-stroke compression ignition engine has a piston stroke of 10.5 centimeter. It means L value is given. L stroke value is given. Cylinder bore of 11 centimeter. So D value is given. At a mean piston speed of 7 meter per second, the developed brake mean effective pressure is 65 kilopascal. The brake power in kilowatt developed by the engine. So as I was discussing that formula, no, mean speed equals to 2 ln and power is equal to PLAN into n by 2. So we will use that formula. See, power equals to PLAN into n by 2. P, effective mean power value, is given. L, piston stroke is given. A is given because diameter is given here. N into number of cylinder is given. So we can easily solve this. Mean piston speed is 7 meter. So mean piston speed, as you know, 2 ln. 2 ln equal to 7 meter per second. So ln value will be 3.5 meter per second. So this ln value will directly put into the question, into equation. Area you can calculate because bore is given 11 centimeter. So pi d square by 4. So pi into 0.11 into 0.11. You can see I have kept all the value in the SI. So it was given in centimeter. I converted it into meters. So 0.11 into 0.11 upon 4. So this will be the area. So now we'll keep P value is 650 kilopascal. So 650 into 10 to the power 3 into ln is 3.5 into A is 3.514 into 0.11 into 0.11 divided by 4 into number of cylinder is 4 upon 2 because it is 4-stroke engine into 4 divided by 2. So sorry, finally when you will calculate, you will get the value of power 43.24 kilowatt. 43.24 kilowatt. So B will be your answer. I'll repeat it once again. P value is given 650 into 10 to the power 3. ln you have calculated from here 3.5. A value you calculated from here, and n is number of cylinder, that is 4 upon 2 for 4-stroke engine. So when you will multiply it, you will get the value of 43.24 kilowatt. So B will be your answer. So next topic I am going to cover here is air standard cycle. So there are two type of cycle, Otto cycle and diesel cycle. I'll not explain it in brief, just refer some of the reference book. So these two formula is important for its efficiency, for efficiency of Otto cycle and efficiency of diesel cycle. So efficiency of Otto cycle is 1 minus 1 upon r to the power gamma minus 1. Okay, so this equation you should remember, 1 minus 1 upon r to the power gamma minus 1. R is compression ratio and gamma is specific heat value. Okay, and in diesel cycle it is little bit complex. So remember, write same equation here, 1 minus 1 upon r to the power gamma minus 1, put a bracket, then alpha to the power gamma minus 1 upon gamma into alpha minus 1. So alpha is cutoff ratio. Actually cutoff ratio is V3 upon V2. You can see here cutoff ratio is volume 3 upon volume 2 is cutoff ratio. So that value, so alpha to the power gamma minus 1 upon gamma into alpha minus 1. So these all will be value will be given in the question. They will provide you compression ratio value, specific heat value and cutoff ratio value. Just you have to put it into the equation, or sometime what they'll do now, so they'll provide V3 value and V2 value, so you can calculate this alpha value by dividing V3 upon V2. So there is one very important question asked in GATE 2015 on this concept, that I'll cover in next video lecture, that is IC engine part 3, because I am having lack of time. So in maybe 2 more video lecture series will come, that is part 3 and part 4, and this in this 4 part we'll cover overall IC engines. So if you are finding our lecture series useful for you, please like, subscribe and refer to your friend. I hope we'll manage to make some more useful video for you. Thank you.